Okay, I'm going to show you now the use of some of these different definitions for the cosine of 2a. In calculus, there are times that it is hard to deal with things that have a cosine squared, and we would like to have, I'll show you the same thing for sine squared and tangent squared. We would prefer it to not have a degree of 2. So you have what are called the power reducing identities. And the power reducing identities are basically a way of saying, can I redefine cosine squared a as something with a degree of 1? So if you just thought about it and added 1 to both sides, and I'm going to switch the order to write it as 2 cosine squared a is equal to cosine of 2a plus 1, and then divided both sides by 2, I could say that the cosine squared a is equal to 1 plus the cosine 2a over 2. That is the power reducing formula for cosine. I could do the same thing for sine. If you remember, we had previously said, let's see if I can switch colors. We previously said that cosine of 2a is also equal to 1 minus 2 sine squared a. So if I wanted to get the sine squared alone, I'm going to bring this cosine 2a over here and this guy over there. So I could say 2 sine squared a is equal to 1 minus cosine of 2a. And so sine squared is equal to 1 minus cosine of 2a over 2. Now please note, in both of these formulas, this one here and this one here, I cannot cancel that 2. Okay? This 2 is inside here, so I can't say it's 1/2 minus the cosine of a. That would be wrong. And this one being 1/2 plus the cosine of 2a. What's nice is look how similar those two are. Cosine squared is 1 plus cosine 2a over 2. Sine squared is 1 minus cosine of 2a over 2. This is, again, it's very helpful in calculus to see those. If I wanted to find tangent, then when I did tangent, I would just choose the sine over cosine. So if I had tangent squared a, I would say that's sine squared a over cosine squared a, and then represent this. If I have 1 minus cosine of 2a over 2 all over 1 plus cosine of 2a over 2, if I actually flip and multiply, this would simplify to be 1 minus the cosine of 2a over 1 plus the cosine of 2a. So with each one of those, I have given you a power reducing formula, an identity, to say that in calculus, again, there are times that having cosine squared is difficult to deal with, so let's change it into 1 plus the cosine of the double angle over 2. If I have sine squared, I can do that as 1 minus the cosine of the double angle over 2. And if I have tangent of some angle squared, it's not the angle squared, the cosine of the angle quantity squared, it would be the 1 minus the cosine of the double angle over 1 plus the cosine of the double angle. Those are referred to as the power reducing identities.